Go.
All right, I'm not here today, so I'm going to do a quick review of rational numbers versus irrational numbers, and then you're going to be doing some work with them. So first, rational numbers are numbers that are fractions or that can be turned into fractions. So we're talking about all integers, so all positive and negative numbers, all whole numbers, all counting numbers are all rational numbers. Any sort of decimals that terminate, that means that they stop. For example, 0.25 is a terminating decimal. That can be turned into a fraction. So any decimal that terminates can be turned into a fraction. It is a rational number. All decimals that repeat are also rational numbers. So a decimal like 0.3 repeated or 0.33333 can be turned into a fraction 1/3. So if you see that bar, you know that it's going to be a rational number. Numbers that are not rational, so they're irrational, are numbers that cannot be turned into fractions. So these are numbers that don't repeat a specific pattern. So for example, the square root of 2 or 3.141592, so pi, doesn't repeat something specific, so it can't be turned into a fraction, and it's irrational. I'm going to show you a few more examples. Okay, these are all examples of rational numbers. That means numbers that can be turned into fractions. 0.75, it's a terminating decimal. That's 3/4. 0.21212121, you can see that there's a pattern here. It's repeating a pattern. That means it can be turned into a fraction. -7/2, that is a fraction, so it's a rational number. And -3 repeated is 1/3, so that can be turned into a fraction. The next examples of our irrational numbers, which means they cannot be turned into fractions, that would be a number like the square root of 2 or 8.1256127. You can see there's not a pattern here, so we cannot turn that into a fraction. And same with 3.141592, pi cannot be turned into a fraction. Okay, so what I'm going to have you do, I'm going to have you look at the 19 examples, and I want you to just label as rational or irrational. Now we're going to go over those examples. So if you look at the first example, 61 pi, that means 61 times pi. That's 191.6371. I can see that the decimal part isn't repeating anything, so that cannot be turned into a fraction. That is irrational. Number 2, rational. 42 can be turned into a fraction, 42/1. Number 3, rational. I can see that this is going to repeat, which means it can be turned into a fraction. Square root of 101 is 10.049875, and it keeps repeating. That is irrational, cannot be turned into a fraction. Number 5, rational. I can see that it's going to repeat. 6 is rational. It's already a fraction. 7, pi, irrational. 8, rational. I can see that there's something that's going to repeat. 98/16, that is a fraction, so it's rational. 39 is rational. It can be a fraction, 39/1. 89.39668, there's not a specific pattern that it's repeating. That cannot be turned into a fraction. It's irrational. Square root of 17 is irrational. 67.714813 cannot be turned into a fraction, irrational. The square root of 64 is 8, that's rational, can be turned into a fraction. 1/4 is rational. The square root of 25, that's 5, that's rational, can be turned into a fraction. 17, it's repeating, rational number. 7/54, it is a fraction, rational. And 19, irrational. Okay, I'm going to have you turn it over now and try the few on the back. Okay, now we're going to go over those ones on the back. If you look at the first one, it's asking for just irrational numbers. So that's B. I know that in my first example, A, the square root of 36 is 6. That's rational, so it can't be that one. Here, the square root of 81 is 9. That's a rational number. And if I'm looking here, I can see this repeats, so I have a rational number, so it has to be B. Which set only contains irrational numbers? That's D. All of these square roots when you find the square root of those numbers, they cannot be turned into fractions. You're going to see that the decimal doesn't terminate or repeat. Which set contains only irrational numbers? That's going to be C. Which set contains an irrational number? So you can see I circled the irrational number. The square root of 52 is irrational. Which of the following is an irrational number? That's the square root of 3. Which of the following is irrational? The square root of 24 is irrational. This is a fraction. Square root of 81 is 9. And negative 4.07 terminates, so those can all be turned into fractions. Which list contains only rational numbers? That's going to be A. The square root of 9/4. The square root of 9 is 3, and the square root of 4 is 2, so that's 3 over 2, so that is a rational number. And the last one, what type of number is the square root of 26? That is irrational. Okay, so I'm going to have you try a few on Edge Elastic, and I hope you understand rational versus irrational.